This is brought to you by the Alumni Association of PISJES.
Measuring devices. And this will be about zero errors on a micrometer screw gauge. If you do not know about the zero error, then watch the previous video and you will have an idea about what a zero error is. Those who have an idea would know how to calculate a zero error on a micrometer screw gauge. So, first of all, let me show you how a zero error on a micrometer screw gauge looks like. Basically, we know that first of all, before taking a reading, we just turn the clamp, as in we just rotate the thimble scale to the point till the anvil and the spindle, they come together. This is the anvil and this is the movable spindle. When they come together, as in I'm just showing you the space, it's not there when they come together obviously. So when they come together, we just turn the ratchet once to make sure we are not exerting too much pressure. So when we rotate the ratchet once, it gives us a click sound, and that means that the pressure is normal. So before taking a reading, this is what we do initially to find out whether the zero, this is the datum line on a micrometer screw gauge, and you must have seen the mic. If you don't remember, then kindly review the video of the micrometer screw gauge so that you know what exactly I'm talking about here. This is the datum line, and we do this procedure to check whether the datum line is perfectly coinciding with the zero mark on the thimble scale. If it is coinciding with the zero mark, then we know that there is no zero error, and we will use the same procedure that we have learned, and the reading that we get will be an accurate one. However, there will be several cases when this will not happen, because as I've told you earlier, because of the usage, and if it's used in a rough manner or even without that, this is a technical fault. So most of the times you will have a situation when the datum line, for example, this is the datum line, this is not perfectly coinciding with the line with the zero mark on the thimble scale. Zero mark on the thimble scale will either be here, this is case 1, or if this is the datum line, the zero mark is here. In these cases, we say yes, there is a zero error. There is a zero error. Now, our job is to identify the magnitude of the zero error. Once we have done that, we can just simply subtract or add from the readings, and we'll find out the accurate reading. Let me show you a case here. I have a picture here with me, like always. This is the case of a no zero error, when the datum line is perfectly coinciding with the zero on the thimble scale. This is a no zero error. However, just ignore this for a while. Just focus on this. The datum line is not coinciding with the zero here. However, it's coinciding with some reading here. So we will find out the zero error in this case. This situation is called a positive zero error. For example, this one. This is a positive zero error. Sorry, this one. This one is a positive zero error. When something like this happens, this is the datum line, this is your zero mark, and this is, for example, 1, 2, 3, 4, 5, 6, 7, 8, whatever. This is going on. So this line is coinciding with a line above the 0 mark, with a mark above the 0 mark here. This is called a positive 0 error. And this means there is already a reading. There is already a reading that needs to be subtracted from the final answer to give you the accurate one. For example, let me just clear it here and change the color. Okay. For example, in this case, here, in this case, 0 is coinciding with the second mark. So to find out the 0 error, I would just say, since the 0 is coinciding with the second mark, I will multiply this with the accuracy of a micrometer screw gauge, the 2. So 2 times the accuracy of the micrometer screw gauge is 0.01 millimeters, which means 0.02 millimeters. Now this is our 0 error. Since our micrometer screw gauge is 0.02 millimeters ahead of the readings. When it should be 0, it's 0.02. So it's 0.02 millimeters ahead of all the readings. So for example, if I find out a reading is 17.6 millimeters, I don't know why I'm taking this number, but I am. This is just a random number. For example, if I just use the procedures and found out the a reading which is 17.6 millimeters with a micrometer having a 0 error of 0.02 millimeters, which is a plus 0.02 millimeters. So what I will do, I will have to understand that this reading is 0.02 millimeters ahead or more than the original reading. So what I will do to find out the accurate reading, I will simply subtract the two of them. So 17.6 minus 0.2 would give me 17.4 millimeters. This is my accurate reading. Because the micrometer screw gauge was 0.02 millimeters ahead when it should have been 0, I have to subtract 0.02 millimeters from all the readings. This is called a positive 0 error. However, in a case like this, when the 0 error is coinciding with a mark below the original 0 on the thimble scale, then it's a negative 0 error. As in, the thimble scale should have been on 0 if there was no 0 error like this, but it's lagging behind. It's not on 0. There is some minus thing in here. I mean, if it covers a distance of, for example, 17.6 again, then first it will have to cover this distance and then the 17.6 millimeters. So it will have to cover some extra distance here to reach to 17.6 millimeters. So in this case, you can see we'll count from this side now. 1, 2, 3, and 4. The 0 is coinciding with the 4th mark. So the procedure is the same. You will just say the 0 coincides with the 4th mark, but on the negative side. It's on the negative side because it's a negative 0 error. Negative 0 error. Since the 0 mark on the datum line was coinciding with the mark below the original level, so it's a negative 0 error. Now what you will do is simply 4 times the accuracy of the micrometer screw gauge, which is 0.01 millimeters. This is 0.04 millimeters. Now since it's a negative 0 error, you should identify since it's below the original 0 here, so this would be a minus 0.04. So all the readings, for example, the reading is 8.2. I used the procedures we have learned earlier, and I found that the final reading with a micrometer having this 0 error, I get a reading which is 8.2 millimeters. Now, since there is a negative 0 error, so this means that it is covering this extra distance and then reaching 8.2. So the actual reading would be 8.2 plus this little covered distance, which is 0.04. So the original reading would be 8.24 millimeters. This would be accurate. So it's always a good practice to check for 0 errors. So this is the positive and negative 0 errors. Now let me just revise it for you one more time, like we always do. Now, how do you identify a positive 0 error? You identify it this way. If the 0 on the datum line is here and the 0 on the thimble scale is here, and the reading, the mark that it is coinciding with is above the 0 on the thimble scale, then this is a positive 0 error. And if, for example, this is a 3, so we say the third mark is coinciding, we multiply it with the accuracy of the micrometer screw gauge, 0.1 millimeters, so this gives us a 0 error of 0.3 millimeters. And since it's a positive 0 error, we always put a plus sign here. This is again an arbitrary sign. If you want to take it as negative, you can, but then in that case you will have to take the negative 0 error as positive. So I take it as positive. So it depends on you. It depends on your ease and your convenience. The point is that you should understand that it is 0.03 millimeters ahead of 0 before even starting. So then what you do is you take the final reading using the same procedures and minus your 0 error to get the accurate answer. For in the case of a negative 0 error, how will you identify that? The 0 mark or on the datum line will be coinciding with the point below the 0 mark on the thimble scale. For example, 1, 2, 3. It will be written as 47, but you will not take it as the 47 mark. You will start counting from here. 1, 2, and 3. It's coinciding with the third mark below the 0 on the thimble scale. So this would be the third mark below. You multiply it with the accuracy, and this would be 0.03 millimeters with the negative sign. Now you take a final reading and simply add this 0 error to get your accurate answer. Remember that we are adding it because this is some extra distance that the micrometer screw gauge had to cover before giving us a final reading. So we'll have to add that and take that in account. So guys, I hope you understood this, and if there are any queries, kindly write them down in the comments box. And thanks for watching, guys.